Petri, for that very nice introduction. And I'm really, really grateful to be able to speak here today because as Keigo-san has already very well pointed out, it has been very frustrating over the last 2 weeks that everywhere it's always only about supply. And it has really, the IPCC has really shown that we will not be able to upscale supply, clean supply so fast. So we really need the demand side. So today I was asked to talk about cities, especially developed country cities. So what I'm going to talk about is how can urban space and society in 2050 be in balance with planetary boundaries. And this is the figure from IPCC, well, the sixth assessment report. This is really iconic that the first time also IPCC has put demand on top of, sorry, I can't show, so I should show that on the top of all other sectors, showing that first you shouldn't first think about where is my next kilojoule of fuel coming from, where is my next kilowatt hour coming from, but first think about, do I need that next kilojoule of fuel? Do I need that next kilowatt hour for supplying the same services? So that's exactly which has been already very well alluded to by the previous speakers. So I put together a couple of points related to cities in this spirit from the sixth assessment report. And if we can summarize in one sentence from the demand side, the city perspective, and especially in developed country cities, what is really needed is to try to think about not always create new. Of course, it's easy to create a new zero energy building, a new fantastic infrastructure, a new well-planned urban space. But what we need to do is really to use the existing one much better. So what the innovations we need, again, were very well alluded to by the previous speakers, are rather for both technological, but also social innovations, business model innovations, as have been very well told already, to rethink and restructure existing urban space, to repurpose and retrofit and reuse existing infrastructure, vehicle stocks through shared mobility, for example, and equipment, rather than having to build or produce new one where applicable, of course. Let me actually unpack that in 8 key strategies. And some of these I will go into, but I can't in 50 minutes do all. So first, okay, is that. So the first very important, and there is a big emphasis also in the IPCC chapter in this urban form and urban space to enable co-location and of employment, residence, commerce, education, and whatever we have to do. We don't necessarily, even if we have an electric car, we don't necessarily want to be stuck in traffic for hours just to get, let's say, a visa, your Egyptian visa or whatever, but how nice it is enabled digitally. So a lot of our mobility is actually not that we really want, but some of that is forced because we have to go to places where we don't really want to go. We just without that. So innovations, especially as very well told already, digitalization, to minimize this forced mobility. Once you minimize the mobility to still enable the same services that people want in cities, then you can innovate transport and logistics systems to enable and maximize effective, shared, comprehensive mobility services for the remaining urban mobility demand at all different levels of luxury or how you want. And for that is the shared mobility work, for example, by ITEA, but also that is being done under the EDITS project. Now, once we solve mobility, which is one of the key emitters in cities, the other major part of urban emissions are buildings related. In many cities, it's up to 70% of urban emissions are actually from buildings. So net zero energy buildings are very important, and I will unpack this later on in my talk. But this really requires, we can only do this in the majority of the world if we minimize energy and material demand, and I will show this later. And again, this requires retrofitting and repurposing of the existing building stocks and repair of components rather than new and replacement, and longevity and durability. And I was very happy to see, for example, in the scenario of METI, that durability plays a special emphasis because very few other scenarios I have ever seen put durability on the focus, but we found it actually totally by accident that in our building energy model, we were surprised to see that actually in China, it makes much bigger difference than your efficiency of the building makes less difference than the longevity of the building. So absolutely, this is the Cinderella, which is rarely in models. So it was really good to see. Also, material demand is also very important for the same service. As just an example, for example, if you come to this venue and you see all these giant structures, or in front of hotels, these very imposing big material things, we need to be more innovative, and art needs to be more innovative to show luxury or to signal other things without having to use a lot of carbon intensive materials. But if you really want to, at least use bio-based materials. And in general, nature in our city is very important for carbon capture and storage, and also for urban heat islands. But for example, for carbon capture and storage, we always just think about big plantations, but currently trees in cities, urban trees, sequester 7 gigatons of carbon. And every year, 200 million megatons of further carbon are sequestered just by our urban trees. And if we minimize urban heat islands, also the air conditioning needs will be significantly less. Also, in general, integrate the mini and micro ecosystems. In Japan, you, for example, master the microforest, and that's a very nice innovation in cities into infrastructure. And in addition to, in general, maximize green and blue infrastructure where possible, so that we can preserve live soils and enhance urban biodiversity and minimize also further urban heat islands. So these 8, if we manage to implement this, we will live much better in cities, that we will have much more social inclusion in 2050, and we will be balanced with planetary boundaries in developing country cities. So now let me jump into actually the key messages related to buildings, because that's my special area of expertise. And we've done a lot of work under EDITS, thanks to the EDITS project, which also made it very highly into the IPCC report. For example, this is a big review paper that EDIT helped us to do. And the key message of this is actually the key message also the IPCC buildings chapter. Yes, it's coming now. So the important thing is net zero energy buildings. And I'm not talking about net zero carbon, because the important thing is to minimize also energy. So net zero energy buildings are feasible in all climates and are economic for almost all building types, both for new and retrofit. And that is very important, because before that we thought, oh, you cannot do it here and there. No, you can actually do it, and it's mostly economic. And we have shown it through many examples, and there's a lot of evidence shown. But as it requires retrofit and repair and repurposing. As we have said, repurposing comes up in the IPCC report also. So let me now show why I'm saying that the net zero requires the minimization of demand. And that is, we often forget, because with net zero, we just stick a lot of solar panels on the roof. For example, here in this conference, everything, oh, this building is with solar panels. Yes, but we forget that maybe if we wouldn't set the thermostat so low, then actually we would not have to sit here in only jackets and pullovers and scarves and so on. And that also is important. But let me first, the repurposing. How repurposing is really important also socially. This is an example, actually, a case study from the United States. This is a medical center, healthcare center, which it's from a low-income neighborhood. They used to operate for 10 years from a trailer. And the reason why they were able to move to this place, because they used an old warehouse which was left and not used, and it was repurposed. The reason why they could afford to repurpose it, because with energy efficient design, they could resize the mechanical systems by 50% less, and also improvements in the building envelope. So they saved a lot of construction costs and also the fuel energy costs. Also, the interiors were designed with new and salvaged So as a result, they could afford to have this much better situation. So it's serving a lot of social purpose as well, efficiency, and not only demand reduction, not only repurposing, so not only climate goals. So here, let me illustrate on the example of the Vienna Technical University retrofit that why energy efficiency is crucial, or demand reduction is crucial to net zero. And this is where actually I have to admit I made one of the biggest scientific mistakes of my life. I published about how it's in certain building types, it's not possible to go to net zero energy buildings. This was typically one high-rise commercial building with lots of internal heat gains, and very high electricity use, very little surface, very little insulation, especially in Vienna, Central European, no way. But fortunately, real life engineers don't read my science, so they actually did it. So that was the old building, and this is now the actually energy positive building, which is now kind of a power plant, the 21st century power plant, producing more energy than consuming. But in the end, I wasn't that stupid to say that, because before the retrofit, it was consuming more than 800 kilowatt hours per square meter per year. It can only produce, even with most innovative design, only about 60 kilowatt hours per square meter per year on with photovoltaics. Even a very efficient office building in Vienna consumes 458 typical new office kilowatt hours per square meter per year. So this is still about almost 10 times bigger than this. So I wasn't that stupid. But still, let's see what actually the engineers have done, or what was the trick to still making net zero. So this is the 450, which is a typical Austrian office building with a lot of uses. Don't worry what it means. It's simply all the kinds of things that we do in a commercial building. And this is what they have done. They have optimized all of these, and they have optimized 9,300 components. This is not rocket science. There wasn't anything fancy, big technology. It's simply looking at all the coffee machines and all the elevators, all the security systems. And as a result, they could reduce the energy consumption by 90%. Once you do that, so for 56, is immediately, so 56 is less than 61. So with this major energy demand reduction, they managed to make an energy positive building. And this is, I think, generally true for net zero in the climate era as well, because to reach net zero goals, we really need to reduce demand drastically. And this example shows that, yes, you can reduce demand without actually affecting the service. The students still get exactly the same luxury, the same nice, in fact, much healthier indoor environment. So yes, less for doing more for less, as the edits, scenarios, and narrative go is absolutely possible. And this is an example. And it's absolutely essentially, especially for the low income. This is a passive house in Budapest. Now we have a major energy crisis. We are next to Ukraine. We are not getting natural gas. So these, and everybody is really worried about the winter, how we can survive, how we can pay our energy bills. Now they will have no problem. This is a social housing in Budapest. They will have no problem, because even if their gas bills goes to 10 times, they still pay very little, because they spend just about 10 euros or something like that per month for the heating bills, because it's a passive house. And but of course, often the argument is, okay, but it costs a lot. No, we have also shown both, thanks to EDIT project, we got a lot of evidence, and from the actual professional literature, that no, passive house level construction can cost even less on average than regular construction. So no, it is not going to cost more. So more with less can be even economic. And what's really important, again, we only talk about kilowatt hours and fuels and gas and oil, but we don't talk about what it is used for. In Europe, half of all final energy demand is for heating and cooling. And today, and most of that is for space heating. We don't need all of that, because in a passive house, in a very well-built building in Europe, because we don't have so much cooling needs as in Japan. In Europe, we have many heating needs. You don't need that. In a passive house, you virtually don't need any heating, or practically no heating. So with upscaling, the examples that I have shown, the case studies before, this is our model thanks to the EDITS project. What we are showing here is that just upscaling these types of buildings and retrofits. Most all European countries get rid of any imported natural gas by the 2040s. So we don't need either LNG terminals or nothing. Of course, you have to bridge this period, but this could be steeper. This is just a very leisurely rate of retrofit. So even an energy security benefit is very high as a result of more for less. However, so this is our scenario for the world. That was for Europe, but this was for the world. So if we only do NDCs, we roughly result in this building energy consumption. So even though building floor space globally will roughly triple in the period, but building energy use will still going up. As opposed to that, if we implement just the best practices in every climate zone and building type, and our model assumes full thermal comfort. So there is no fuel poverty anymore. Nobody is cold. Everybody has full thermal comfort, both for cooling and heating. So everybody has enough access also to air conditioning. You can actually reduce building energy demand despite the tripling of this floor space by over 50%. And as opposed to if we only look at the interim scenarios of the NDCs, roughly this is implies an increase in 30%. So, but the problem is because buildings live for a long time, there is a very big lock-in risk. Every building that we build from today or retrofit today to less than a net zero future level, this means the locks us out of of carbon neutrality or a net zero building energy sector by the middle of the century, because our building emissions in 2060 or 2050 are determined by how we build and retrofit our buildings today. And yes, that's the lock-in. There is a big lock-in risk, which we also warned in this Nature Climate Change publication. So finally, what I have shown through just a few examples, that there is a broad spectrum of opportunities that can make cities more livable. Yeah, party, see? More livable, increase social inclusion, increase social cohesion and well-being, as Joyashri and her chapter shows really well, and increases local economic activity. This is a nice example from Barcelona, which illustrates so many things because they closed this really busy road. There is a lot of cafes on the side. There is a lot of bicycling and walking. People are healthier. There is cooling through the big trees, so there is not so much heat island effect. And also our mental health, the IPCC also showed and emphasized that urban green space improves our mental health significantly. So this is much better for everybody and still keeping within planetary boundaries and meeting net zero emission goals. So yes, we can at the same time really do better for less. And thank you very much for your attention. And that's a party because we can live much better for less. Thank you. I hope it jumps to mine. Yes, thank you.